Welcome back one more time to Dave Does Math from Home. This is part 2 of our video about section 3.7. We're talking about the chain rule, which is how to take the derivative of composite functions like this. We already know how to do the derivative of products, quotients. Now things are inside of each other and we're talking about derivatives of those. So, from the first video, we learned that if you're taking the derivative of a composite function like this is the sign of x cubed minus 2x. The first thing you need to do is identify the inside function and the outside function. The inside function is an x cubed minus 2x. The outside function is the sign of the blob. The derivative of this is 3x squared minus 2. The derivative of this, derivative of sine, is cosine of the blob. And then to get the derivative of the whole thing, we just multiply these two things together. Cosine something times 3x squared minus 2. And this something is where most students make mistakes. The biggest mistake students make when doing this problem is trying to put this derivative inside here. The derivative doesn't go on the inside. The derivative gets multiplied as a separate piece. The thing that goes on the inside is the thing that has always been on the inside. The blob never changes. If you start with an x cubed minus 2x on the inside, you better have an x cubed minus 2x on the inside by the time you're done. Whatever the derivative of that is, you attach to the end. That's it. That's the chain rule. Sometimes these things could be simplified. Don't simplify them. Just leave them alone. They're good. They're all set. So once you get the hang of these, they'll go pretty fast. We can do another one. We can probably do another one in this space. Let's do g of x equals e to the x minus square root of x to the 7th. The inside is e to the x minus the square root of x. The outside is something to the 7th power. Derivative of the inside is e to the x minus, I'm going to change the way I've written this. Just finished explaining in the last video that you should never try to take the derivative of a square root because it's a mess. So I'm going to change this. We're going to make it not a square root. We're going to make it a 1/2 exponent, which is a square root. I'm just writing it differently. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. And the derivative of something to the 7th is 7 somethings to the 6th. And so the derivative of the whole thing is these two pieces multiplied together. 7 somethings to the 6th times e to the x minus 1/2 x to the negative 1/2. Into the blob goes the inside unchanged. This will be an e to the x minus square root x. And that's it. That's all you got to do. So you're going to take the derivatives of these things in pieces and then put them together with multiplication. The blob never changes. Don't simplify. I'm going to do a more difficult one. Let's look at f of x equals the square root of e to the x squared minus 3x plus 17x. I'm just making this up. I don't think this function represents anything. To take a derivative, first we need to identify the inside and the outside. The outside here is square root, which I'm going to call blob to the 1/2. And the derivative of that is 1/2 blob to the negative 1/2. The inside function is e to the x squared minus 3x plus 17x. And the derivative of that is another chain rule problem. We got chain rules inside of chain rules. It's all compounded together. So let's come down here. We'll do a sub inside and a sub outside, looking at just this thing so we can find the derivative of just this. The inside thing here is going to be x squared minus 3x. That's what's inside this e to the something. The outside is e to the something. So, the derivative of e to the something is e to the something. E is nice. No changes there. Derivative of x squared minus 3x is 2x minus 3. Individually, all of these derivatives are pretty straightforward. It's putting them all together that's going to make this a little weird. So, the derivative of e to the x squared minus 3x altogether is a lady kitty. This is Tuna. Hey Tuna. Say hi to the camera. There we go. He's so soft. I still have marks on my wrist from the last time we did this and you scratched me. Yeah? Okay. That was a very important interruption. The derivative of e to the x squared minus 3x should be e to the blob times 2x minus 3. The blob never changes, so this needs to be an x squared minus 3x. And then the derivative of 17x is just 17. That part can stay separate. I'm not super worried about it. So, we did a sub-chain rule problem to find the derivative of the inside of our written chain rule problem. So, this chain rule problem has 3 layers. It's one more layer than the 2-layer chain rule problems we've done until now. But we can still put all these pieces together. Work from the outside in. F prime of x equals, start with the outermost derivative, 1/2 something to the negative 1/2. What goes in here? The thing that started in there, e to the x squared minus 3x plus 17x. This is the outermost derivative of this chain rule. We multiply this by the derivative of the inside, which we found using a subchain rule. So this is getting multiplied by e to the x squared minus 3x times 2x minus 3 plus 17. I'll use parentheses here as well. That's it. It is possible that this simplifies. I'm not going to look at it long enough to find out. I'm already done looking at this thing. Whatever mess I have placed on the board behind me, I'm finished with it. Maybe it simplifies. I don't care. I'm not going to find out. We're leaving it as is. Derivative of the outside, derivative of the inside. Derivative of the inside sometimes has extra pieces because additional chain rule events. I'm going to do another one like this with a chain rule with lots of different pieces. And then in part 3, we'll talk about more exciting things that we can do with a chain rule. So let's do f of x equals, I'm going to see if I can come up with something that's like a chain rule that has like 4 pieces. So let's start with no, I already did a sine one. Let's start with a cosine one. Let's do a cosine of the cube root of, no, cosine of e raised to the cube root of x squared plus 2. Yeah. For a problem with this many layers, I'm going to start skipping the inside-outside just because I don't have enough room on this board to write down the inside-outside for all the 3 or 4 different layers that this thing is going to have. I'm just going to work very slowly and very carefully from the outside in, adding derivatives of the new pieces each time. So, f prime of x equals, the outermost piece here is a cosine. Derivative of cosine is negative sine. The blob never changes. E to the cube root of x squared plus 2. This is the derivative of the outside. I multiply this by the derivative of what's in here next. The next layer in is e to the something. The derivative of e to the something is e to the something. That something should be the cube root of x squared plus 2. So this is the next layer in. I'm multiplying this by the derivative of the inside here. The derivative of a cube root, let me make a little sci-fi here. The cube root of x squared plus 2 is x squared plus 2 to the 1/3. So the derivative of that should be 1/3 x squared plus 2 to the negative 2/3. So again, don't try to take derivatives of radicals, change them into fractions, and then take the derivative of the fraction using the power rule. It's much, much easier every time. So this is the derivative of the inside, so that's what comes next. 1/3 x squared plus 2 to the negative 2/3. Now I have to multiply that by the derivative of what's inside here. The derivative of that is 2x. And now I'm done. If you're doing lots of steps like this, it's sort of tempting to keep multiplying by derivatives of whatever's in the parentheses until you can't anymore. You have to know when to stop. We don't need a derivative of 2x because 2x already is the derivative. It's the derivative of this. So this is where you stop. You don't need any additional derivatives. This is itself a derivative of the innermost piece. So we're done here. So this you can think of as a chain with 4 links. Piece 1, piece 2, piece 3, piece 4. That's why this is called the chain rule. You can make these as long as you want. So this is my shortcut for a really long one. You're not really going to see stuff like this often. Generally speaking, I think it's worth writing down the inside, outside, taking derivatives, multiplying them together. I think sort of doing this the long way is usually the right way to do these, the best way to approach them. Once you have lots and lots of practice, like say if you've been teaching calculus for a decade, then maybe you can start to do these shortcuts. But start with the long way. Get that practice first. That'll do it for part 2 of this video. I'm gonna start part 3 with some other exciting things. There's more to talk about.